All right, let's talk about something huge. What if I told you there's one fundamental trick that can completely transform the way you build software? I'm serious. It's the thing that takes you from being just a builder, slapping code together, to a true master architect, creating systems that are robust and built to last. You know that feeling, right? You start a new project, it's exciting, everything's moving fast, but then it grows and it gets messy. All of a sudden, it's this complex, fragile thing, and making even a tiny change feels like a nightmare. It's like you've built this massive skyscraper, and now you're terrified that changing a single window might just bring the whole thing crashing down.
Yeah, if that sounds familiar, then you've probably fallen into what we can call the builder's trap. It's what happens when your whole project is basically one giant single piece, a monolith. And the problem with that is every little change means you practically have to rebuild the whole thing. It's just so inefficient and honestly super risky.
And this really gets to the core difference in how you approach the problem. See, the builder's way, well, it ends up as this tangled mess. You change one little thing over here, and suddenly three other things break over there. But the architect, they think differently. They design with these clean, independent modules that just fit together. The whole system becomes organized, stable, and just way, way easier for you to work with. You know, a lot of the time, this happens because of what people call vibe coding. And we've all been there, right? You're in the zone, you're building fast, it feels great, but you're not really thinking about the big picture, the architectural plan. And the result? You end up with a system that just can't scale. It's an unmaintainable mess down the road. Okay, so how do we get out of this trap? Well, the solution is actually centered around one single incredibly powerful principle. This is it. This is the fundamental trick that separates the builder from the true professional architect. And that trick? It's called modularity. It's a simple idea, but it's profound. It's all about breaking everything down into smaller, independent, self-contained pieces. Now, the set of rules, the toolkit we use to actually do this, that's what we call the solid principles. All right, let's grab the first tool from our architect's toolkit. This one is all about one thing: focus. It's about making sure every single piece of your system has one and only one clear job. Let's use a real-world analogy to make this super clear. Imagine you're designing a house. You would never, ever design one single massive room where people cook, sleep, and shower, right? It would be total chaos. Imagine trying to fix a leaky pipe in the shower while dodging the bed in the stove. It makes no sense. And that idea translates directly into our code. A house has specialized rooms, right? A kitchen for cooking, a bathroom for, well, you know. Your code needs the same thing: specialized classes. Your order processor class, its only job is to process orders. That's it. Need to send a confirmation email? Nope, that's not its problem. That becomes a totally separate job for an email sender class. So this brings us right to the formal definition. It's called the Single Responsibility Principle, or SRP. And it's simple. A class should have only one reason to change. Think about it. If you need to change your email format, the only thing you should have to touch is the email sender. The order processor shouldn't even know or care. Each module has one job, and it does that one job really well. Okay, let's move on to the next principle. This one really builds on that idea of stability, and it shows us how we can let our systems grow and add new things without constantly breaking what's already there. Here's another analogy for you. Think about the electrical system in your house. How insane would it be if you had to tear down a wall every single time you wanted to add a new lamp or plug in a new device? It's unthinkable. We have a much, much smarter system for that. And here is the key concept. The wiring that's already inside the wall, that is closed for modification. You don't touch it, it works, you leave it alone. But the wall outlets, those are open for extension. You can plug in any new device you want whenever you want. And in code, it's the exact same idea. Your core stable classes are closed for modification, but they are open for extension, meaning you can add new features by creating new classes that build on top of them. So that's the formal rule, the Open Closed Principle, or OCP. It says a software entity should be open for extension, but closed for modification. The key takeaway? Extend, don't edit. It's that simple. All right, now let's quickly cover the final three principles. These are the ones that really make sure all of our independent little modules can be swapped out, combined, and connected together reliably. This is what turns our collection of parts into a single, cohesive, working system. Okay, let's just run through them. First up,
the Liskov substitution principle. The analogy is perfect. Think of a standard light switch. You can replace it with a fancy dimmer switch, and the room's lighting still works because they both follow the same basic rules. In your code, it means you can swap out components without the whole program breaking. Next, there's interface segregation. This is like giving a plumber only the plumbing blueprint for a house, not the master plan with all the electrical and HVAC stuff. You don't want to overwhelm them. Your code should do the same. Only give a module access to the tools and information it absolutely needs to do its job. And finally, dependency inversion. This one's about depending on contracts, not concrete things. A carpenter needs a tool that hammers, not necessarily a specific brand of hammer. Your code should work the same way, depending on abstract ideas or interfaces, which makes everything way more flexible.
So, after all that, what's the big payoff? What does thinking like an architect actually do for you and your projects? I mean, why should you even bother? Well, the benefits are just huge. Seriously, you'll work faster because you're only focused on the small parts that actually need to change. You'll be way more efficient because when a bug pops up, it's trapped in one little module, making it super easy to find and fix. Your whole system is just less prone to breaking. And maybe the most important part, your own thinking changes. You just naturally start to design with these independent interlocking parts right from the get-go.
Look, when you master these principles, you make a fundamental shift. You're no longer just a builder, reacting to problems and patching things up. You become a true architect. You're the one designing elegant, robust systems that are built to last. So now you have the secret. You have the foundational trick of a master architect. The only question left is, now what are you going to build?